Hey, Mr. Mises here. This is 2-1C, lesson 2-1, and in this video we're going to talk about the intermediate value theorem. So we're talking about essentials of calculus. So here we go, 2-1C, intermediate value theorem. Let's talk about it. All right, so the first thing you need to know is that there are three things that you need to know. I just repeated myself. Three things, conditions of the intermediate value theorem. So three things you really want to focus on. The first is that f is continuous on the closed interval a to b. All right, so it's got to be a continuous function. And their k is any value between f of a and f of b. So that k value has to be on the y-axis between f of a and f of b, whatever values that you plugged into your function for a and b. Okay, so this is the first thing. This is the second thing. Then the third thing is that there is a value c somewhere on the x-axis, so somewhere over here, right, in between a and b, such that f of c is equal to f of k. I'm sorry, f of c is equal to k. So when I plug this c into my function, I'm going to get a k value that ends up being between f of a and f of b. So that's what the intermediate value theorem states. You know, it's almost kind of like a duh, okay? If this is continuous and the value is between these two y values, then there's going to be a c value that's in between a and b on the x-axis. That's what we're talking about, all right? So let's take a look at some examples on what this would look like in your calculus class. So does the intermediate value theorem guarantee that there's a c value on the given interval? So again, we got to test three things for this to guarantee. So the first one, we'll just write them out, okay? First, is f of x continuous on the interval, or first of all, is f of x continuous on the interval from 0 to 5? All right. Well, yes, this is a polynomial, right? This is a polynomial, so I will just state f of x is continuous on the interval 0 to 5. Okay. Second thing, is k in between f of a and f of b? So let's check. So what we gotta do is we gotta check f of b. So we got to plug in, and we're going to get 20. And we got to check f of a, which is 0. And so since f of c is equal to 12, this is k, and k is in between 20 and 0. So since 12 is between 20 and 0, we're good to go. All right, so that checks off number 2. Let's check off condition 3. So since both of these happen, all we're going to say is the intermediate value theorem guarantees. I guarantee. Spell it right here. Guarantees a c value in the interval 0 to 5 such that f of c is equal to 12. All right? That's it. That's all there is to it. So you just got to check the three things. Okay, let's check the next one here, b. All right, let me turn myself. Wow. That make you seasick. Just turned. All right. So now, notice here we've got, if I simplify this, okay, stay still, computer, to x plus 2, x minus 2, over x minus 2. These cancel out, but still, what happens here when these simplify out? What happens? There's a hole, right? There's a hole at x equals 2. So if there's a hole at x equals 2 is in my interval there, right? So a hole is a removable discontinuity. It is a discontinuity all the same. So my first step is to see if this was continuous, and I say no, g of x is not continuous on the interval 0 to 3. So if it's not continuous, boom, I'm done. The IVT does not apply. and then I'm done. All right, that's all you got to do. So if it fails one of those first two things, then the conclusion can't be met. All right, find the value of C in example 9a. So let's go and find the value of C. So what do? Well, we found that it works. So what we're going to do is we're going to plug C into our function. All right, so I'm going to have f of C is C squared minus C, and that should be equal to 12, because I know right here it says it's equal to 12. Okay, so we're going to solve for C now. Okay, so we're going to take C squared minus C minus 12 equals 0. So we're going to bring the 12 over. We're going to factor. And we either get C is 4 or C is negative 3. Now, which one of those is in our interval? Well, our interval was 0 to 5, right? So if our interval is 0, C needs to be in 0 to 5. Which one of these works? 4. All right? So C equals 4 is the one that works, because this one's not in the interval. All right, does that make sense? I hope so. I mean, I'm asking you, does it make sense? And if you said, yeah, it makes sense, then good. I didn't hear you say that, but hey, it's good that it does. All right, so there you go, guys. That is the intermediate value theorem. We'll catch you guys soon. Bye.